So I still don't get it. Why is it done on build? So there are people who are doing, creating assets, and there are people who are doing code, right?
Mm-hmm.
So when people who are doing code want to build, then you do the asset thing, upload, download, whatever. So why is it not done? Whenever an artist hits save, you do everything, upload it there, it's fine. That's one question. And the second question is, you say you pre-populate 10 different. So why 10? Why are assets not in a single place and just streamed every time?
Okay. So I'll answer the second question because I remember it the most. But so the reason why we pre-populate like 10 and that we don't just land everything into the one location is for versioning. So I believe in versioning absolutely everything down to even your versioning system. And for that reason, we want to have multiple developers and multiple teams working on separate things at the same time, right? So it's possible that, let's say 10 or 20 different people will be making different changes all in art, and all of the art files are large binaries, right? So you can't really merge them nicely. And for these, you want to enable them to have their own game client with just their changes from a known stable pool of different changes. And for that, you need them all to be separate. So there's no inherent versioning of asset bundles unless you make it yourself. Like you just say to the game, grab me the latest files from this URL. So because of that, the way we currently do it is we just have different buckets in Amazon S3, like different paths per different game client version. And that's like an ever increasing incremental number. So it like guarantees uniqueness in the game clients, but it also means that we can measure through like Cloudflare or whatever peaks in certain versions, and can also deliver over-the-air changes to a certain game client. For example, let's say we have some game client that's live in the world and we want to deliver a content-only change. Like let's say we got the flag for Ireland wrong and mess it up with something else. Like we could change just that flag, dump it into the same asset bundle, and it would just stream in automatically the change. But that would be considered a art hotfix. But it would also not require a new client to be downloaded by a user. So it just streaming automatically. And I can't remember the first question.
So the first one was because the developers are not changing assets. Why not, build them all just when the artists are doing them instead of doing what difference is when they are making the build, because they're not changing them, right? They could have been since yesterday there. Why build them on the code build?
So build on code build because the main code build needs to have a master index of all of the available assets at build time, for the reason that some assets in some cases need to be prepackaged with the game client. The kinds of assets that you'd have prepackaged with the game client depend on what exactly it is that you want to that first time user experience to be. So if I open up the game and we know that, well, for a user that's never played before, they're going to go to this part of the game, we should just have those assets already in the prepackaged game that they download straight away. And we can tweak that based on analytics, saying, oh, well, most people go for this kind of troop, so we should prepackage that, or you see these things more often in the actual end user experience. So I guess that doesn't actually answer the question of why don't we just do all this work once on asset changes. And the reason why we don't want to do that is because it's possible through compile flags and code level changes that different assets will actually end up in the game, or that the assets will be built differently. So through code changes, you can say, I want the music to be encoded at this quality. And those are the kinds of changes that are hard to track if you're only concerned with, well, this asset has landed in. And they're sort of linked, but actually managed separately. Yeah.
Thanks.
Is storage cost in this case a concern? Because it sounds like if you have X art assets in question and a developer will only change maybe one per time it builds, then X minus one are just being copied and copied and copied every time.
Yeah.
So is space costs or storage costs a concern here, or is it cheap enough that you're not worried about it at the moment?
Storage is free.
Right, okay.
Yeah.
I mean, it's free enough that just no one cares about storage costs. I mean, like currently we have terabytes of data that are assets and most of them are stale. But on Amazon you can move those to like Glacier storage if they're infrequently accessed. We just happen to keep everything lying around because, I mean, why automate something that's, like it costs me more to automate it
Yeah.
than it costs us to just leave them there.
Okay, fair enough.
Oh yeah, just one. So in AWS, you mentioned there is no way to speed up upload, but there is now. Right? You can upload it directly to CDN, and then it will propagate further. So have you tried those?
So that's new since about 12 months or so.
Yeah.
I looked into it, and I can't remember the exact reason, but it wasn't solving our issue of uploading a bunch of stuff. I think it only solves the problem where you're uploading from somewhere that doesn't already have a data center nearby. So we're uploading to the Dublin data center, so it's like
So next door, right?
you know. But I think the uploading through CDN, I can't remember what the Amazon term for it is. That this helps when you're in somewhere that doesn't have an edge node nearby. Or no, sorry, somewhere that has an edge node but not a data center for Amazon. Yeah.
Okay.
Because then it just goes to the internal Amazon network.
So on the Unity side, have you looked into building in RAM or?
So interestingly, at build time, everything is maxed out with RAM. So it doesn't really touch the file system. It does like this sort of stupid, lazy import and dumps that all to file, and then scoops that all up again, sees what's changed, and then does a big, massive compile job, you know, across like using Clang and various different like asset importers and, you know, converting assets from one format to the next. I think the real wins there are actually more towards where we're managing the way that we actually build the asset models themselves. So right now we have like a sort of a lazy scan through all of the files, build up an index, scan through all the files again, see how many files you've got that match the index, and like there's a whole bunch of like stupid stuff that we're doing there.
Kind of next question is, have you looked into using Union FS to kind of do the quick delta between what's changed between the versions?
Yeah, so like Union FS could be pretty nice for us, but we're just storing all of our assets on S3 as raw files. So I'm not sure if that would work within the context of accessing them over S3.
Is that a copy on write?
It is, so it's, you only get the delta between the two local copies on disk, so
Yeah.
you would have a very fast way to see what files have changed.
Yeah, well, first of all, with Union FS, you have an overhead in writing to disk all the time. But secondly, these files are actually stored just on raw S3. So on our workstation, like, we've got all the files. The difficulty is more about how do we get them up to S3 so that they can be accessed via CDN or whatever.
Just kind of more questions on that same line. It's the chunked or the chunked upload that's probably the benefit there. That gives you the delta between the binary blobs of the file.
Mm-hmm.
So is it the size of the binary blobs that don't get copied, or have you gone down to that kind of level yet?
Oh, so actually what we're doing is we're taking like thousands of individual files, of unknown size, I suppose, and just dumping them up to S3. But what you can do is, obviously with the pre-copying, you can use like an AWS command line argument which just says only upload the ones that are different to the ones that you've already got. So it just does its own sort of scanning of, well, what's changed between these files locally and these files that I know about.
Okay, so it's not a large volume of large binaries, it's a large volume of tiny binaries?
Well, it's a large volume of binaries, some of which are small and some of which are large. But large in the context of this is like 100 megabytes or something. So at this point they've been split up into more manageable pieces. 100 megabytes is maybe a bit large there actually. Might be something more like 50.
I know the underlying parts of the S3 protocol, you can actually batch or chunk up your file into multiple parts.
Yeah.
And you can actually get the checksums of each parts in the remote and check the checksums that way. So if it puts them together back in the same binary order, you could do the deltas and only upload the deltas that way.
Oh, right, yeah. So this is interesting. In the case of an asset bundle that's been built and changed, the entire asset is changed. So it's like,
it's a new binary.
like the input binary is totally different. To the extent where it's like probably was some PNG file which has changed drastically because Unity will suck that up and turn it into a Unity specific format. And I don't know the inner workings of how that is done, but it's non-trivial. Any other questions?
Yeah, it's very similar. We had a pretty similar issue in work where, like you said, sometimes it's the burden of what you know, then sometimes it's the benefit of what you don't know.
Yeah.
And like that, our service artifact for the mail service was like 25 gig-ish, and the particular pipeline we put together, they wanted a single change in one of the components, the service artifact being a composite of those components, whereby one change, one component, one service artifact, and that goes off to commit testing. And it was 25 gig to create an instance of it, and fortunately this particular developer was quite nice, and the implementation was based on rsync, so it took care of the deltas for us, assuming you actually had an initial state. And in our original case like that, we didn't. So one of the things we came to a similar conclusion and started caching, or in this case we created just an initial seed where we'd have some sort of just batch job which would just create the latest version and just duplicate it 3, 4, 5, 6 times, and then we'd pop off the stack, take an instance, and it didn't matter what the prior state was. It wouldn't be linear, but it would certainly be less than the whole lot, or as little has changed since the last time. And in our particular case, we were able to leverage rsync to take care of the delta and compute the actual difference, and then it actually does the incremental for us.
Yeah.
We found out we cut down through all of that and got from the service artifact take about 40 minutes to build. Majority of that was actually just pushing network traffic up to 25 gig. Seeding that, we cut it down to 20, and then we realized we were on a ship pipe internally, so we got a gigabit and a hard backbone onto, I think, the fiber channel, and we cut that down to, I think, 5-ish. And that's actually including, like that, just having an idle batch job, which, albeit remote, will call to the file share, and we'll literally just from the file share just push and pull stuff up there, so that the next time we go to make the service artifact, there's some version up there that we can just cache off in 5-ish, 6-ish minutes.
Yeah, this is exactly the same thing. You know, it's the cost of uploading, you know, raw, just far outweighs the cost of uploading on top of literally anything else. Yeah, it's exactly.
But like in that case, no one knew what the hell the artifact was. We just knew this thing's 25 gig and it's freaking massive. But we didn't know, we didn't care. Someone was just like, this is just taking like 40 minutes. How, why, and what can we do about it? And it's nearly better having known like that, you know, oh, it's deterministic, you don't need to rebuild everything. And someone's just like, well, it's just file copies, and if we can just figure out how they differ, then we just move what differs if we can have an initial state. So like that, sometimes, yeah, you can have the burden of knowledge, but the benefit of not knowing it, and just working to what you don't know.
Yeah.
That's all of it? Yeah. Cool. All right, everybody.
Thank you.
Very much.
Thank you.